Hello and welcome back. We'll continue looking at section 3.1, and in the last video we were looking at graphing quadratic equations in a very particular form. Well, this is generally how we'd seen quadratic functions in the past, so let's look at how we might graph these. And to be honest, it's easier to graph things in the other form. So right here, what I've done is I've shown the steps to take ax squared plus bx plus c down to the form that we had before. Now, these steps are not necessarily important to learn. However, looking at this final equation, I have written this in a way that we can read off, for instance, the vertex of the equation. And the vertex for ax squared plus bx plus c is the following. The x value is going to be negative b over 2a, and the y value, the height, is a little bit of a mess, c minus b squared over 4a. The easier way to remember this, this is the thing that you should memorize. And what this says is that the x value for the vertex of an equation that looks like ax squared plus bx plus c is going to be negative b over 2a, and then the y value is whatever you get when you plug negative b over 2a into your function. Again, this is just what a function is. The function describes the y values for each height. So we'll go through an example, and then what you'll notice is that the steps to graph a function in this form is exactly the same. You look to see if it opens up or down. If a is positive, we open up. If a is negative, we open down. We find the vertex, which we will simply have to use our new formula, negative b over 2a, and what you get when you plug it into the function. We find the x-intercepts, we find the y-intercepts, we plot the points and connect them. This is exactly the same method for the other form. We've just got to do a little bit more work to find the vertex. So let's do that here. We'll graph this function and then we'll find its domain and range. So first and foremost, we can see that our first number here, a, is going to be negative 1. So our function is going to open downward. Opens downward. So 2, we'll need to use our formula to find the vertex. So we know that a is going to be negative 1, but we also need to know b, which is going to be 4. So the x value for the vertex, the x value is just going to be negative b over 2a. So we've got a negative 4 over 2 times negative 1. And the negative signs will cancel out. 4 and 2 will cancel out to just get 2. The y value is just the height of the function, and this is going to be exactly what we get if we plug 2 into our function. So we'll plug 2 in. So negative 2 squared plus 4 times 2 plus 1. Negative 2 squared, this is going to be negative 4. 4 times 2 is 8, plus 1 is 5. So the vertex is going to be at 2, 5. And again, for a very rough sketch of what's going to happen, our parabola is going to open downward at the point 2, 5. So 2, 5. And then it'll open downward. So something like this. So we'll expect 2 x-intercepts and 1 y-intercept. So to find the x-intercepts, we need to know when the function height is 0, as in we need to know when 0 will be equal to negative x squared plus 4x plus 1. And to do this, what I'll do is I'll just use the quadratic formula. So again, we have a is negative 1, b is 4, and and c is 1. So we'll have negative b, so x will be negative b plus or minus the square root of b squared minus 4 times a, which is going to be negative 1, times c, all over 2 times a, which will be negative 1. So let's simplify this. Negative 4 plus or minus 4 squared is 16 plus 4, so that's going to be 20 all over negative 2. Simplifying some more, the square root of 20, notice that 20 is going to be equal to 4 times 5. So the square root of 20 is the square root of 4 times 5. So this is going to be plus or minus the square root of 4 times the square root of 5. All this divided by negative 2. So if I distribute the negative 2, I will have 2 plus or minus the square root of 5. So these are the x-intercepts. The y-intercept is just what we get when we plug 0 into the function. So negative 0 squared plus 4 times 0 plus 1 is 1. So we now have all the ingredients necessary to graph this. So our vertex was at 2, 5. Our y-intercept is at 1. And our x-intercepts are at 2 plus or minus the square root of 5. The square root of 5 is about 2.24. So if I take 2 minus this, so it'll be about here. And if I take 2 plus this, it'll be at 4 and a little bit more. So our parabola is going to do something like this. It's not a perfect drawing, but we've got the vertex, the y-intercept, and x-intercepts, so we can just connect the dots. And what you'll notice here, the question also asked for the domain and range of the function. The domain, the question is, what x values are we allowed to plug into the function? Well, when our function is just squaring a couple numbers, there's nothing that we can't plug in. So the domain is going to be all numbers. Whereas the range, we have our maximum value right here. So 5 is going to be the highest this ever gets. So the range, all of the possible y values, is going to be anything from 5 and below. So going all the way from negative infinity, way down there, up to 5. And in fact, this is incorrect. We can hit 5 exactly. So we will use a square bracket because we can get 5. We do want to include 5 in that interval. So with maximum and minimum values, this is pretty straightforward. If a is greater than 0, our function opens up, which means we've got a minimum. And we have the formula for the vertex, and that vertex is going to be where the minimum is. So the x value is going to be negative b over 2a, and the height of that is just going to be the height of the function. So we plug it in. If a is less than 0, again, now our function opens downward. Our vertex is the maximum, and we know where that happens. The x value is at negative b over 2a, and the height of the function there, the maximum itself, is what we get when we plug in negative b over 2a. So let's look at this function. We've got 4x squared minus 16x plus 1,000. So the question is, does f have a minimum or a maximum? So just to be clear, we've got a is 4, which is a positive number. So our function is going to open upward, which means that it has a minimum. Easy peasy. Let's find the minimum or maximum and where it occurs. So again, the vertex is where the minimum is. So to find the vertex, we have our formula. The x value, so where it happens, is going to be at negative b over 2a. So b here is negative 16. 2a, that's 2 times 4. So negative 16 is going to be 16. 2 times 4 is 8. So the x value is 2. So this is where the max is. Now if we want to figure out how high the function is there, we can look at the y value there. Now the y value is just given by the function, so this is just going to be f of 2. If I plug in 2 into here, we'll get 4 times 2 squared minus 16 times 2 plus 1,000. And, oh, that's not 1,000, this is 1,000. So 2 squared is 4. 4 times 4 is 16. Minus 32 plus 1,000. This will be 984. So this is the maximum value. So just by plugging this in, we can find the maximum value. And then if we want to find the domain and range, again, the domain of a quadratic function is always going to be negative infinity to infinity. And why? What values of x can we plug into this formula? Well, there's no restrictions. I'm not taking the square roots of any negative number. I'm not dividing by 0 anywhere. I'm allowed to plug in whatever x value I want. So the domain of the function is just going to be negative infinity to infinity. However, the range, because this opens upward, I've been using the word maximum here, when in fact we said it was a minimum to begin with. So you'll have to correct that. So since we have a minimum, 2 is where the minimum is at, as in along the from left to right, and the minimum value is going to be 984. So it's going to be way up the top. Now, since this is the minimum value, the smallest height that this can take is 984. But if that's the smallest, we can get even bigger. And a parabola is going to open up forever. It's going to keep going up and up and up. So we'll go from 984 to infinity, and we want a square bracket around 984 because we can actually achieve our minimum.